What's up, guys? Last video on Redox. This time we're really going to dig into what the keywords mean. Before we do, please like, subscribe, share, keep growing the channel. First of all, let's get into this. Oil rig. You'll have heard this mnemonic before. Here we're talking about oxidation is loss of electrons. Reduction is a gain of electrons. So you'll certainly have heard that before. Maybe into at GCSE, this is probably a bit of a revision. Now we're going to look at what these other terms mean, right? So we've got redox, and here that's a type of reaction where both of these things have happened. Now, a disproportionation reaction is a very specific example of a redox reaction. So, example or a type of redox reaction where same species is oxidized and reduced. And what we need to be able to do, we need to be able to identify redox reactions and thereby work out what's being oxidized and what's being reduced. We also need to be able to identify disproportionation reactions. Now, we can also think in these terms, right? So here, if something is oxidized, we've already said it's lost electrons. We can also say that it is a reducing agent. We can say it is is equal to a reducing agent. And what that means is because it's oxidized itself, it has also reduced something else. It's lost an electron and given it to another species, right? And in turn, in this reaction, we're also going to have something that's being reduced. And we can also call that an oxidizing agent. We'll sort of look at that within some examples here. So first thing we need to be able to do in these is we need to be able to remember how to work out our oxidation numbers. And again, I'll put the link there as to how we do that. Now, first of all, let's work out what our oxidation numbers are. So magnesium, elemental state, so that is 0. The hydrogen is going to be +1 here. Chlorine, -1. The magnesium here, now it's in a salt, so it's now going to have its +2. The Cl2, each of those is -1, and our hydrogen's in its elemental state, so now it's 0. So we've got two pairs, right? We've got our magnesium here and our magnesium here. We've also got our chlorine here and our chlorine here. So, sorry, not our chlorines, but our hydrogens. Our hydrogen here and our hydrogen here. So, here, if we think about this movement, in order to go from +1 to +2, we've gone from Mg has lost 2 electrons to make our Mg2+. plus 2e minus. So there, this has been oxidized, so we can also call this a reducing agent. If we look at hydrogen, we can see what's happened there is we've gone from 2H plus, we've gained 2 electrons to make H2. And there we can clearly see this has been reduced because it's gaining 2 electrons. We could also call it an oxidizing agent. So absolutely, this is a redox. It's not a disproportionation because the same species is not turning. Next. So again, chlorine, Cl2 is 0 there. With H2O, oxygen is 2 minus. Each of hydrogens plus 1. Here we've got plus 1, minus 1. And here we've got an interesting thing where the oxygen is clearly going to be minus 2. The hydrogen here is plus 1, which means in a strange turn of events that this chlorine is now plus 1. So here, I hope you can see, we've got two different things. So we've got our chlorine here, and we've got our chlorine here. Now, let's have a look at these. So our chlorine here, we've gone to, let's say, half Cl2, has turned into a Cl minus. So it's gained an electron in order to do that. Right? So here, this is reduction because it's gained an electron. We can also say the Cl2 here is acting as a oxidizing agent. Then we've also got the chlorine here, where we've got our other half of our Cl2 is making a Cl plus. And this time it's lost an electron. So this is this strange thing I was talking about where we've got a disproportionation reaction. So this time we've lost an electron. Therefore, this is oxidation. We could also call it a reducing agent. So we say that this is both a redox reaction and it is that specific type of a disproportionation reaction. Great. So slightly more complicated. Let's look at the examples that we've looked at throughout this, throughout these half equations and combining half equation segments. So oxygen minus 2. So the vanadium here must be plus 4. Oxygen, we've got 3 lots of these minus 2. So the Fe must be plus 3. Oxygen minus 2. This time the vanadium is plus 5. Oxygen minus 2 still. And the Fe is 0. So we've got two things that you really need to pay attention to. We've got our vanadium. And we've got our iron. So let's start off with our vanadium. So we're moving from V4 plus to V5 plus. So clearly an electron has been lost here to make that happen. Therefore, this is oxidation. We could also call VF4 plus a reducing agent. The next Fe2 to Fe here. There we've got Fe3 plus to make Fe, and 3 electrons have been gained in order for that to happen. So this is clearly reduction, where we've gained electrons. We could also say the Fe3 plus is an oxidizing agent. So redox, yes. Last one. Oh, disproportionation, absolutely not. Last one. Again, the Fe2. So we've got 3 plus here. The oxygen is 2 minus. Plus 1, minus 2. Cl2 is in its elemental state, so 0. Here, iron's in its elemental state, so 0. Here, Cl, so we've got minus 2 for each of the oxygens. So we've got minus 6. This must be plus 5. And then 6H plus 1. What are the ones we've got to worry about? Fe again. And our Cl. So, our Fe has gone from Fe3 plus to Fe, same one again, plus 3E minus. So it's gained electrons. So it's reduction. We can also call it an oxidizing agent. And our next one, we've gone from Cl2 to, let's say, 2Cl5 plus, and so we must have lost electrons here, plus 10E minus. So there again, oxidation is lost. We've lost these electrons here. We can also call Cl2 a reducing agent. And again, we tick to show that it's a redox. So 3 questions for you to give a go. Using this sort of same idea, it's a good culmination of the topic. I'll answer this at the end of next video, where we will start to look at rates of reaction. Before that, let's get into this. So, combining 1 and 3, remember our whole thing is we've got to balance our electrons. So doing that, we need 4 lots of number 1, right? So let's times everything by 4. Let's combine all of our reactants. So we've got 8 lots of H2O plus 4 lots of I2 plus 8 lots of E minus plus 8 lots of H plus B2O4 reacts to make. Now we'll do all our products. 16H plus 8 E minus plus 2V plus 4 H2O. What can we cancel? So first, we'll definitely cancel our electrons. We can cancel some of our H pluses. And I think, nope, that's not quite it. Get rid of those as well. And then we can write out our final answer. So we've got 4 H2O plus 4 I2 plus B2O4 makes 8H plus 2V and I forgot the 8s. silly. I forgot the 8s. IO minus. Remember this times by 4. I forgot to put that here. Silly. Right, last one. 2 plus 3. So again, we've got to times everything here by 4, haven't we? So that we can balance out our electrons here. So again, same strategy. We've got 4 lots of H2O plus 4 lots of Cu plus 80 minus plus 8H plus V2O4 reacts to make. Now all of our products, not forgetting the CuO here, 4CuO plus 8H plus 8E minus plus 2V plus 4H2O. Again, cross out. We obviously need to cancel out our electrons. The H plus cancel, the H2O cancel. Perfect. 4Cu plus V2O4 makes 4CuO plus 2V. Hope that helps. Happy revising. I'll see you next time. If you haven't already, please like, subscribe.